Lesson 5. This is actually going to be a lesson on graphing the square root function, which hopefully in a lot of ways is a big review. We're just going to go into some detail, but it's basically the same. What is the parent function? The parent equation or parent function is basically the simplest square root graph we have. So it's y equals square root of x, or if you want to use function notation, it's f of x is equal to square root of x. Okay? The square root of x graph is what this first part of Unit 4 is about. We've been talking about square roots. We've been talking about exponents with square roots. Okay, now it says complete the table and graph the parent function. So I've got some numbers in here. If you'd like, we're going to use our calculators. Is we're actually going to type. We grabbed our calculator and we've typed in square root of x. Now what Miss Jessup wants us to do is actually find and fill in the table. Okay, so when x is a 0, and can you actually think what's it going to be before I look at the table? What if this is y squared of x? What if I let x be a 0? What's the square root of 0? Anybody already know? 0. Everybody good? So 0. I would fill that in with the 0. All right. If I go to the table, does everybody see the numbers? The square root of 2, that means what number times itself twice is 2? It turns out to be 1.414. So I'm going to round that off to just 1.4. Okay, what's the square root of 3? Again, not a perfect square. Nope. It says it's 1.7. I used it in my table. Okay, go to x is 3 and make it 1.7. What's the square root of 4? 2. What's the square root of 9? Go down to 9. What's the square root of 9? 3. So I'm trying to pick some perfect points, but I need you to understand there are going to be some points on the graph, if you tried to graph each point, that are not perfect points. So, like we said, that's 1.7, this is 2, and the square root of 9 is 3. Give me 3 key points that if I only had to graph 3, I should be able to get a picture of the graph. Well, I think 0, 0 is pretty important. Why? Right? Because I have to have a starting point. This is a graph that starts, and it just has one side. Yes, ma'am. 1, 1. That's an easy one. X1, Y1. Give me another perfect point. Probably 4, 2. Now, 9, 3 would be nice if we always have a big piece of nice graph paper. Sometimes we have a small piece. So, 1, 1. 4, 2. And in this case, we do have 9 and up 3. Does that look like half of a sideways parabola that we've actually graphed before? Okay. So we're taking more time. Now we have to talk about domain. Domain is a set of the what? X's. So I'm going to say, what happens on the right-hand side? You got an arrow. It's going right to positive infinity in the X direction. It's also climbing slowly, but it's climbing up to the what? Positive infinity in the Y direction. Okay? So remember, it's less than. Coming from the left, imagine sweeping farthest to the left to farthest to the right. What is the very first X number we cross? We cross at 0. So it would be 0 on the left. I'd like to point out, guess what number X is in the graph? It's 0. It's my first point. How far does it go? Goes to infinity. Okay? Now, I do need to show the equals because it actually does touch right at the 0 mark. So I do need to put the equals. But I got to tell you, you will likely not see this version of, they do not show the 1/2 of a side that's got infinity on it. And what they're going to do is they're actually going to flip this around. Imagine flipping the whole thing around. And they're going to say the X's, are the X's less than 0 or greater than 0? They're greater than, aren't they? If I flip this whole thing around, boop, it would say X's are greater than or equal to 0. That is the best way to represent it because it's implied. If we say it's greater than 0, it's implied that it's everything greater than 0, all the way to the big, big, big numbers, all the way to infinity. Does everybody understand that? Okay, what about the range? Lowest to what? Lowest to highest. Lowest to highest. Okay, so again, Y in the middle, less than, starts at 0. How high does it go? Goes to infinity. Are they going to show me the infinity side? Not likely. It also needs to have an equals with 0. Okay. Now this time imagine taking your hand right here across the y-axis, come up the y-axis. Am I going up from 0 or am I graphed down from 0? Up. Is that greater than or less than? Greater than. My y's are greater than or equal to 0. Everybody good? Okay. What's my x-intercept? Go across the x-axis. Where does this graph cross? 0, 0. My y-intercept. Take your finger down the y-axis. Where does this thing cross? 0, 0 again. Now, I do need to include this terminology. I didn't when I did x squared, and I should have. But I'm trying to go back to that document that says, here's what you need to teach. It's called the MRI document. I'm supposed to talk about to you, when is it decreasing? Is there an interval over which it's decreasing? Is this graph ever decreasing? Not this one, never. So I would say there is no interval or none. Okay. Oh, I did that last time. Last class I did the same thing. It should be none right here. There is none. There's no interval of which is decreasing. This graph is always doing what? Increasing. It's going up, up, up. So what interval? From what x to what x? From x what? 0 to how far? To infinity. All x's that are greater than or equal to 0. It's always going to be tied to your domain. The interval over which it's increasing. And I probably should have spent more time talking about that in terms of the parabola, because it does decrease, and then it stops decreasing, and then it does what? Increases. So it does have intervals of both. This is called end behavior, and I saw a question that I just need you to know that phrase, end behavior. What's it doing at the end? And here's all you need to think about. As x approaches what? Does that mean my x numbers are getting bigger or my x numbers getting smaller? Bigger. So if I go to x bigger and bigger and bigger, what's it says? Where does the graph or the y's go? Where do they go? What do you call that when they get bigger, bigger, bigger? Where are they going to? They're going to what? Positive infinity. I've been showing you those arrows. We've been talking about it. I've just never expressed it like that. And I just want it to be something that you've heard. So as x's get bigger, 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 y's get bigger, bigger, bigger. Okay? So as the x's get bigger, where do the y's go? These three things you already know. Not going to spend much time on them. You've got a number on the what? You got a number out front. Okay, that number is going to make it vertically stretch. It's going to get taller, or it's going to shrink it. It's going to vertically stretch or shrink the graph. This graph's either going to get taller or it's going to get squattier. It's going to get shorter. Next number is the number where? The h is on the inside. What does that number on the inside make it do? Makes it go what? Left or right, but what? Does that sound familiar? Have we ever talked about that before? Isn't that the exact same behavior that the last graph that we did? So we've actually done this before. We just need to apply it to square roots more specifically. Where's my k value at? My k value is actually where? It's that number on the outside, added or subtracted. What does that make a graph do? Not go left and right, but it makes it goes up and down how? Up or down. Same as the what? Remember, if you, not a great thing, but if you're in jail, if you're inside the jail, you're in there because you're probably doing opposite of what society says you should. And if you're outside, the assumption is you're doing the same as what society says you should. So that's just a way to remember. Opposite or same. A little bit of a typo. It shouldn't say for any square root graph. Should be what we call the parent. The parent graph is that simple, simple, simple square root graph. Where does it always found at? Where's the start point at? 0, 0. Remember, that's always starts right there in the center of the graph. We always started right here. Remember how I said I always want you to compare every graph that shifts back to that one. We've done these before. Let's see if we can just pull that memory. Okay, is the 3 on the inside or outside? Okay, it's the inside. It goes left or right, but it goes what? Opposite. What's opposite of negative 3? Positive 3. Is that right or left? That's right. Right, 3. Okay? Does that make sense? You remember doing these? I hope you do. Okay, plus 4. Inside, right? It's left or right. It's going to go to what? It's going to go left 4 to negative 4. Now, there's 2 things in C. Tell me what 2 things. I have a negative out front. Anybody remember what that does? Okay. The negative makes it flip down. Across the x-axis. What does the 3 make it do? Does it make it stretch or does it make it shrink? It stretches. It stretches by a factor of 3. Yeah, it shrinks if it's smaller. See, basically what they're saying is we're going to go up. Instead of going over and up 1, we're going to come over and up 3. So we're going to stretch it higher than normal. Okay, where's the 5 at in part D? It's on the outside, so that makes it go what? Up 5. What does the next one do? Minus 6. That one makes it go down 6. There are 3 things that I need to say for F. What 3 things should I say? Right 2, up 7, stretches, up, factor 3. Right 2, up 7, stretches up, factor of 3. It's kind of like we're just specifically narrowing in on just talking about square root graphs. Okay. Okay, start the domain and range. Now, start point. Do you all remember when we talked about the inside number and then we talk about an outside number? Do you remember that? We did this for parabolas. And the one on the inside came out, guess what? Opposite. But the one on the outside came out how? Same. Okay. Where does this one start? 0 and 0. It has no number on the inside. It has no number on the outside. The only thing it does, if I had to draw letter A, it looks the same. Like if this is the original square root of x, then this one that has 5 would actually look like this. That would be 5 square root of x. Does everybody understand? That graph just stretches upward 5 times farther each movement. Okay, what's my domain? Here's what I want to point out. What letter do you associate with domain? X. X, X, and X. And every one of these is one-sided, so we just need X on one side. What letter is associated with range? Y, 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 Y. Okay. Domain. Sweep your hand across the x-axis, right? What's the first x number you get to? 0. Now, is it 0 greater than or is it 0 less than? Am I greater than 0 or less than 0? Which way does the arrow point? Greater than. X's are greater than or equal to 0. Everybody see that? Ron, help me out this next one. Take my y's. Range is the y's. What's the first y number I get to? First y number. 0. Now, am I 0 going up or am I 0 going down? Up. Is that greater than or less than? Up is greater, isn't it? So y's are greater than or equal to 0. Can I show you something? I know this won't make much on this one, but my x number was 0 and my x number had 0. On my y number I had 0 and on the range number I had 0. Don't mean much right now. It will for the next one. Okay. Is there a number on the outside? No, not a number on the outside. So this one comes out what? Opposites would be what? Negative 8. And this would be plus what? 0, so that'd be 0. What does that graph do? It doesn't go to positive 8, it actually goes to negative 8. So if I was going to sketch, and Miss Jessup likes to see a sketch, I'm going to go back to negative 8, and that's where it starts. Here's my graph. That's what it looks like. Okay, let's do the domain. Sweeping across the x-axis, what's the first x number you come to? Negative 8. Okay, put a negative 8 there. Am I greater than negative 8, or am I less than negative 8? Greater. And it's going to have an equals on it, because none of these are going to be open circles. Okay, let's talk about the y's. Let's come up the y-axis. 0. Is it greater than 0 or less than 0? Greater than 0. And it's going to have an equals. Can I point out? My start point had an x value of 8. My domain had that same x value of 8. My range had a y value of 0. And my range was had the same y value. Do y'all see how we're breaking using the x and the y from the start point? That start point's really, really important. Anybody know my start point for C? Positive 7. This one comes out opposite. So positive 7. And what number's out here? 0. So that one must go what? If I was graphing letter C, I'd come 1, 2, 3, 4, 5, 6, 7. Okay. What does that negative out front make it do? So what used to be up here is going to be what? Down there. Does that, everybody see it flips it down? Do y'all remember us doing these? Okay. That's the graph I got to go with this time. Okay. Sweep your hand across the x-axis. What's the first x number you come to? 7. So I need a 7 right here. It is going to be equal. Is it greater than 7 or less than 7? Greater than 7. Everybody see it? Now, let's go to y's. I go right here to the middle. Am I going, what's the number in the middle? 0. Is it less than 0 this time, or is it greater than 0? This time it's what? Less than. Less than 0 or equal to. Again, are you noticing anything about the point? 7 is an x, and the range or domain starts with 7. 0 and 0. Woo, it's taking forever, isn't it? Last one, what happens? Negative 2, negative 3. So you kind of know where it starts. Negative 2, negative 3. Anybody know what number I'm going to have with my domain? And what about my range? We know it's going to be equal. We just don't know if it's greater than or less than, do we? Or do we? Okay, I'm going to imagine. Remember, it goes to negative 2 and then down 1, 2, 3. Right there's my start point. There's nothing out front, so it doesn't flip. It goes like that. So, right? That point's negative 2, negative 3. Greater than or less than on x's? Okay, greater than. Greater than or less than on y's? Greater than. Are you understanding a little bit about if it goes forward, it's greater than. If it goes up, it's greater than. Yeah. If it goes down, it's less than. That's what I need you to know. We haven't done domain and range where we just specifically did it with less than and greater than. This is one-sided. They will not show you that other half, so I need you to, okay. Whew, going fast. You ready for me to go quick? Okay, here we go. What's the only thing that's going to happen in 11A? It's going to flip down. So the same numbers I had a while ago, 0, I had a 1, I had 1.4, I had a 1.7, I had a 2, and I had a 3. They're all going to now be what? They're all going to be negatives. Because the negative out front is going to make them all be negative. So 0, 0, over 1, down 1, over 2, down 1.4, over 3, down 1.7, over 4, down 2, and over 9, down 3. Okay, what's my start point? 0, 0. What's my domain? X's, Come across the x-axis. What's the first x number we touch? There was x and a y. It's going to be 0. My range is going to be y's and 0. I need no greater than or less than, guys. Which one's less than? Okay. So, okay, what you're saying is I go to 0 and I go less than's back here, greater than's are over there. Greater than. Let's go y's. Y's. Greater than or less than? Less than on the y's. Because it goes down. It goes down as less than. Graph does. You're looking at the graph. As x approaches positive infinity, so if x gets bigger and bigger and bigger, where's the y's going? Where are they going? Negative. To negative what? Infinity. Interval decreasing. Oh, no. Oh, that's why we don't always want to open the windows. I think the windows has made it hotter today. Interval of which is decreasing is x is greater than or equal to 0, and it's not increasing. All right. That's my observations. This thing does not increase, it only decreases. This thing's only going down, 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 down. We're talking about the y's. Comparison to the parent function, it reflects down. My parent function used to go up. This thing has flipped down. Where'd it go?
It's up there in the bonds, but I can't reach it. If I had a fly swatter, I might be able to. I was going to spray it.
Yeah. Usually I hit it with like a jacket or something, knock it down and stomp it. I'm not allergic, thank God, but it can create a panic. Oh. Thank you. Oh, it's still. As I start nut letter B, I now have a new graph. I can either take each number one at a time and put -5 in for x. What's 3 times -5 in for x? What's -5 plus 5? 0. What's the square root of 0? 0. What's 3 times 0? 0. So the answer is 0. Now, you realize you can do this with your calculator. Okay, now that we've plugged it into y1, we're going to look at the table and fill in our points. So -4. I need to go up to -5. Yep, -5 was 0. What's -4? 3. All right, what is +4? Anybody got it yet? 9. And what is +11? 12. Okay, give me those numbers again. Okay. We are having a day. We have a bee that has entered our room, so that's where the extra noise is coming from. I just got to go. All right, -5, 0. This thing came left, 5. -4 up 3. Over +4 and up 9, and I don't think we can put the last point on there. That's my equation. That's my graph for that equation right there. Where's my start point? Where's this thing start? -5, 0. My domain's going to have an x, oops, and my range is going to have a y. I'm going to bet $10 that my x of -5 is going to be mentioned, and my range of y is going to have a 0 in it. All right, I want to go ahead and talk about my domain. So remember, we sweep our hand across the x's. What's the first x number we get to? -5, and that's why I already have my -5. Now, am I greater than -5, or am I less than -5? Graph goes to the right, doesn't it? So that would be greater. And it is always going to be equals, or we don't have any open circles on this graph. Anybody know what the range is? Let your hand come from lowest. Now, and it's 0. Now, is my graph greater than, or is my graph down here less than? Greater than or equal to. End behavior. As x approaches 0, so if I go across the x's and they get more and more positive, where's the y's going? What does that arrow tell me? Where are they going? Up to what? Positive infinity in the y direction. So that's that question would be going up to positive infinity. Is this thing decreasing ever? No. There is no interval over which it decreases. Does it increase? Yes, the entire time. Every x value from -5 forward, it is increasing. How does this compare to the original parent function? Well, it went what? Left, 5. What else? Then it went up. You see the 3? Did this thing not go up much faster than normal? Remember, the original graph would actually be here. This is the original x. That one got stretched vertically up. All right, so it got stretched up factor of 3. It's got stretched up. So in other words, this thing it's almost like you grab it on a chain and you pull it up and it goes up higher. We got one more to go and we're going to wrap this up. We ready? Is this all sounding somewhat familiar, like we've done it before?
Yeah.
It was. I hope that it would. We got one more to go. This one does look a little different. Okay, here we go. I need to fill in my points. Do you want to put one in? What happens if you put 1 in? 4 minus a half. If you put a 1, what's 1 minus 1? 0. What squared is 0? 0. What's 0 times a half? 0. What's 4 minus 0? I think 4 minus 0 is a 4. Is that right? That's a lot of work, isn't it? So if I want to fill in the other points in my table, what can I do to help me? Go to my y equals, and I'm going to type that in. 4 subtract 1/2, 1 divided by 2, square root x minus 1, and then I have to close my parentheses because I don't have the bar that continues. Okay, I'm going to check my table. Has anybody got the table in there? Okay, 5 is what? 3. 10? 2.5. 2.5 is 2. Is it 1.5 and 1? By any chance? 26 go down to 26? And 37 is 1. And we're not going to be able to get all of these points, but I just wanted you to see a pattern. Where's my start point? 1, 4. And so I'm going to go over 1 and up 4. Then I'm going to go over 5 and up 1, 2, 3. Then I'm going to go over 10 and up 2.5. And I'm going to sketch my graph. That is it. What in the world is my domain? My x and my y. My domain is my x's. I'm going to bet $10 that because my x is a 1, that my domain is somehow related to the point that starts at x value 1. What do you think the range is going to have? What number in it? It's going to have a 4 in it. Now let's just see if we got greater than or less than. So when we do range, sweep your hand across the x-axis till you get to the first number. It's 1. Am I greater than 1 or am I less than 1? Greater than. Greater than or equal to. We do touch that point. All right. If I sweep my hand up the y-axis till I get to 4, am I less than 4 or greater than 4? So my graph goes up? Goes down. So that would be what? Less than 4 and equal to. Okay. As x approaches the positive infinity, so as x gets bigger and bigger and bigger, the y's go where? So remember, these go negative infinity, or excuse me, positive infinity x, but they go what? Negative infinity in the y. So they go toward negative infinity. Does this graph have an interval over which it decreases? It always decreases. So from every x greater than or equal to 1, it's decreasing. Has no interval over which it is increasing. Comparison to the parent function. What did this graph do? Well, it went right how many? 1, right 1. Then what? 1, 2, 3, up 4. And it actually flipped what? Down. Flipped down. And it actually did one more thing. Anybody tell me what it did? This actually got vertically challenged. It looked like I sit on it and made it squattier, or did I stretch it? Did I shrink it, or did I stretch it? Okay. If I had this up here, if it was going this way, it looked like somebody sat on it and shrunk it, doesn't it? Okay, and it got flipped. This actually, do you see the 1/2?
Yep.
This actually get what? This thing got shrunk. It shrinks factor of what? Factor 1/2. Does anybody notice that that's not written in the way that we normally write it? That's not written in the way we normally see it, is it? How would I rewrite it if I wanted to? How could I rewrite it? Who wants to chat? Who wants to find it? Does the 4 surprise you that it's in the front? Don't we normally see that in the back? Okay, I think we'd have negative 1/2 square root x minus 1, and then that's a positive 4, so that would be the same thing as what? Plus 4. That is the way we normally see it, because the vertex or the start point would be what? Positive 1 and what? Positive 4. This would come out as opposite, and this one comes out as the what? That's my inside number, and the 4 actually is my what? Outside number. The only thing is they move the outside number to the front, and they can do that. It doesn't matter where it's at.